Hello, everyone. Thanks for joining the Qimera 2.0 webinar today. We're really excited about this major product release containing several new features with a focus on cross-product functionality between Qinsy and Qimera, further integrating those products and making the workflow more seamless than ever, from data acquisition to processing. All right. This webinar will be a full overview of the features new in Qimera, and as usual, we're heavy on demos and light on slides. The demos are pre-recorded for expediency of the webinar, and we do have some handouts available. These you can see those in the webinar handle there. These are the release notes for the new version that contains the details of the new features that are the topic of this webinar. There's also a list of a longer list of improvements that you can read there. As usual, questions are welcome, and I'll pause periodically to answer those. All right. The webinar team today is composed of our managing director and the Qimera product manager, Dr. Jonathan Bodewin, who's in our office in Canada. Myself, Matt Wilson, marketing and sales manager from our US office, and also Evan Martziel, technical business development manager, also from the US office. Jonathan is presenting today, and Evan and I are going to be behind the scenes to facilitate the webinar and help to answer questions. So one last note before I get started, we launched our new website earlier this year, so please go and check it out if you haven't seen it yet. There's loads of product information and as well information on the training and services we offer. And if you'd like to evaluate Qimera or any of our products, there's a button there on the top right-hand side, try it for free. Just click this to easily get started on an evaluation. And also to make it even easier, just during this webinar, anytime if you type eval in the chat window, we'll get you set up with a Qimera evaluation. So, okay, without further ado, I'll go ahead and pass it over to JB to get started. And so JB, it's all yours.
All right, thanks, Matt. Let's see if I can get these slides going on my end. So like Matt said, we're going to focus on the new features today. I'm going to list those off. We're going to try and go real fast and get through each of those. If you look in your handouts, there's a new features PDF. Basically, each one of those we're going to cover with a short video demo. There's a little bit of text in that handout. Those are directly from the release notes. So we'll get through them. I won't spend any more time on this slide. On the next slide, there's also the improvements that are coming in Qimera 2.0 that are just released. That's the longer of the two PDFs. That's also from the release notes. And I've just generally touched on the categories here. We're not going to be getting into the details of these today. That would be a whole other hour webinar, I think. But at the end of the webinar, if we're running a little short and we have some extra time, we'd be happy to take some questions about any of these if you might have read the release notes before the webinar started. So before I dive into lots of narrative over videos, Matt, I'm hoping my audio is okay. Can you just verify that for me?
Sounds good, JB.
Okay, great, thanks. All right, so we'll go real quick here. The new project dialog in itself isn't very exciting. It's a bit of an iteration on what we had previously in Qimera. What is exciting is that this is common across the product line now with Qinsy and Qimera. So there's a new similar startup experience, and you'll see this over and over during the following videos. I won't linger too much on this, but this is one example of a cross-product item that we've really focused on this past while with Qinsy and Qimera. And along the lines of that, the other much bigger cross-product improvement that we have between Qinsy and Qimera, and then coming soon to Fledermaus as well, is a new Geodetic UI. So that's UI as a user interface. And you see some screenshots on the right there. What that does, we've tried to make it easy, intuitive, and faster. We've taken the ideas in the historic Qinsy geodetic interface and also the Fledermaus and Qimera one that was in common, and we've smushed that all together and then tried to make general improvements with the aim of making it easy, intuitive, and faster for all users. There's a map view, as you can see. When you type in the search area, it's predictive, and that the very big EPSG database packs down to just the items you want to search for. So you'll see that in the demo. New to Qimera users is the ability to configure transformations like you've been able to do in Qinsy. Also from Qinsy, in Qimera, you'll be able to set vertical offset models for people that aren't coming directly from Qinsy. You can set up construction grids. Some people call these engineering grids. That's something that's new to Qimera, but that's always been in Qinsy. Another last thing that came from Qinsy is the geodetic test utility. If you have a very specific geodetic transform you need to proof to a client, there's now a utility in this Geodetic UI that lets you do that. And that's in common now between Qinsy and Qimera. And then lastly, Qimera has always supported WKT and EPSG from a Qinsy user's point of view, because we have a lot of Qinsy and Qimera users in the webinar. This is now available to Qinsy users where you can configure things with EPSG codes and WKT. So I'll just jump into a short video demo now showing how to set up a basic geodetic configuration with a vertical offset model. So here you choose the little Edit Geodetic Configuration button, and this launches an overview dialog from which it coaches you through, much like the guided workflow, what you need to answer first. And in this case, what is my map deliverable? Where do what coordinate frame do I have to deliver to my client? So in this case, I've got something for Halifax Harbor. I've got UTM 20 North, and you can see that the list is packing down as I type. So that's the predictive search. When I click on it, it highlights in the map view. And you can see that you can pan around and zoom. And this is just that, the 0th level gut check. Did I get the right map projection? Everybody knows where they're working in the world, but it's pretty easy to convince the software that you're working somewhere else if you make a mistake. So the next stage that you might want to set up is, what's the separation model I need? So here I just start typing Canada, because I know I'm in Halifax Harbor, and I choose that one, and then I click OK. And it warns me that that vertical coordinate reference frame has a NAT83 base ellipsoid. My project frame has WGC84, so we need to configure that. It's done automatically for you. And you also need to configure a transformation. And when you search this time, it takes the EPSG codes for both of those coordinate frames and narrows down the search window for the ones that are applicable to that. And then you click OK. And then that's done. You click Create. Now that's part of your project definition. And what I'll do now is add some raw sonar files. And these are data files that you've seen in previous demos of ours in Halifax Harbor. So we add the files. Nothing changes from this point forward. These are Qinsy DB files, so Qimera will detect what the geodetic settings are in those files as was configured online, and will respect that and then transform it if necessary. And then finally, we'll add an SBET here. So this is the usual workflow for adding an SBET. First, you have to create your custom SBET sensor, because you need to keep it separated from your online sensors. You choose to bring in the height, and you click OK. And that'll start importing. And you'll see Qimera will link that up with the multi-beam data files that you've brought in, and we'll eventually configure it to use GPS heighting. So we'll just process these up. And once that's done, we'll create a dynamic surface from that. So I'll set the resolution to 1.5 meters. Click OK. And there's the surface. And what I'll do here is, the deepest parts of this particular area are about 70 meters deep. And if we brought in an ellipsoid height on the SBET and didn't get the geodetic vertical offset correct, we would not have the depth profile that we have there. So that's just the visual confirmation that the depth did indeed apply correctly. Or sorry, the geoid offset does. So that's a quick demo of the geodetic user interface. There's, of course, many more things you can do with it. What we might do is just a set of separate how-to videos or a separate webinar altogether for Qinsy and Qimera users to really explore the power of that. I just kept it short today. This is one of the most common workflows that's requested for Qimera users that are using different acquisition systems. Okay, so let's jump to the next slide. We'll go to the integrated 3D slice editor. You've seen some posts on LinkedIn about this for quite a while. And what this is the ability to run the slice editor at the same time as a 3D editor and have them alongside each other. Note that the older 3D editor that's standalone is still there, and that's where you would go to do cube editing, for example. What we've aimed to do is provide a 3D point editing experience that you can have alongside with the slice editor. So I've got a short video about that too, so let's jump in. to that. So here I've got the same demo data set I had just opened up, and click on the surface. And typically when I'm doing point editing, I want to look at the shallow surface, color by uncertainty, and then change the color map. If you've ever attended any of our webinars, this is my usual practice. You want to see the shoalist soundings. And you can see right there the big improvements with the shading. There's a lot of spikes in that data just because we didn't have the blocking filters enabled. And they're casting nice long shadows. And realistically, you can zoom out. You can see those artifacts from outer space, really. And that's where the shadows really help out, to be able to see where there's spikes. So what we'll do is draw a rectangular selection just on the grid and have a quick look in the slice editor. So load up the points, and there's the slice editor. And what I'll do is point out the new button on the console for where the 3D editor is launched from. So we're calling this the 3D slice. So to keep it separate from the 3D editor, you click on that button, and it pops up alongside by default. And this has the same mouse behavior as it is in the scene. So you can edit using the left mouse button, and you can pan and tilt using the shift key to modify your mouse actions. And you can edit in both editors. They both update, and so do the points in the scene. And there's another button that lets you control the layout. You see here, clicking on that, if you long press, we can go to a docked 3D slice, which allows you to disconnect that 3D slice from the 2D, and it places it somewhere else. What you can also do is float that dock and put it on a second screen if you've got a few screens. And that just behaves the same as any of the docks in Qimera now. So you can edit there, pan and tilt. And then you maintain the views between the 4D scene in the middle, which has your maps and contextual information like draped images or other types of data. And then you're editing in the point editors. We have the various color by options available in the scene and in the different editors. You can color by ping, for example. And you'll see that the 3D and the 2D slices are linked together in their controls. When you choose the color by options, they change in synchronization. If you change from rectangle select to polygon select in one of the editors, it changes it in the other. So there's a variety of coloring options there. There's a new one to color by the surface map and also by the selection of the Z range in the buffer. So now we'll just look at a couple of other selection modes. This is the fixed slice select. So in this case, you can draw a box, and then there's a slice that's fixed within that box reference frame, and you can only advance it forward and backward. And you can see that the soundings light up differently in the slice editor versus the 3D slice. And when you edit in the 3D slice, it only edits the ones that are loaded in the current slice, so the highlighted soundings. So you can have the full context of the other soundings, but when you lasso and kill dots, you're only editing in the highlighted ones. And then lastly, here we'll show the new free slice. We've augmented this to be able to rotate the inner slice and outer box independently. So you can see that you can position them and then rotate them. Before that, the outer box was only north oriented. So here we'll show how you might use that to isolate some spikes in the scene. What you can also do is show the surface in the 3D slice, and that'll draw as an underlay. So you'll see the spike shows up there, and now your eye is drawn to it, and you can kill that dot and hit save, and you'll see that the scene and the dynamic surface itself updates. And then the color map refreshes too, to show that you've got a better control over the Z range. All right, so that's the 3D slice. There's a lot more to talk about. It's quite well documented and updated in the reference manual, and there's a little bit in the release notes about it too, particularly in the free slice modes and the color by options. So what we'll do now is we'll take a pause for some questions, see if Matt and Evan have any that have come in.
Yeah, JB, one question about the new Geodetic UI. From the previous versions, how does the new geodetic interface improve the workflow of data coming from Qinsy?
Well, the Qinsy motto has always been, if you set it right up online, you shouldn't have to keep paying to remember those settings and reconfigure them downstream. So if you've got it all up and going in Qinsy, it's the exact same experience we've had before. It just works in Qimera. And if it doesn't, let us know and we'll get right on top of that. If you want to make some corrections, you can. So that's if you're opening a Qinsy project directly in Qimera. Clickety-click, it just works. If you wanted to recover from an error online, typically in the olden days, you would have had to do a geodetic reconfigure in Qinsy and then a replay. What we would do with Qimera these days is make a new project, reconfigure the geodetics the way you want them to be, and then you would import your DBs and QPDs. And then if any necessary reprojections or transformations would be done at that point. Any other questions?
Yeah, that sounds good, JB. Let's see. That's it for now, JB. Thanks.
Okay, cool. All right, well, let's keep going. So up next, we have the SVP Crossfade, which I'm quite happy to say is one of the few things that I still got to do a little bit of coding on in this past release. And what this does is it lets you recover from the transitions when you switch from one cast to another halfway through a survey line. If the two casts give you very different refraction solutions, you'll always get a little bit of a bump there from one swath to the next. It'll have a sudden jump because of change in the refraction correction. And this lets you smooth that out. And the basic idea, if I can make an analogy, is let's say you're at a wedding and the DJ is a really good DJ and they want to keep people dancing on the floor. The trick for that is you find songs that you can blend together. As you transition from one song to the next, you turn down the volume on the first song and then you gradually turn up the volume on the next. And that's what this tool lets you do. Instead of switching suddenly in a jarring break, it lets you slowly transition from one SVP to another over a very small time frame. So I've got a video about this that shows that off. To make the story complete, what I'll do is I'll create a problem in this data set that we've been looking at so far. And what I'll do is I'm going to remove two of the sound speed profiles that are in that data set and force it to do a nearest and distance calculation using the two remaining sound speed profiles. One of them is quite deep and the other one's quite shallow. And as you know, if you use a shallow cast in deep water, it's probably not going to do a good job. So I'll run the processing settings. I'm going to switch these all to use a nearest and distance SVP algorithm and click OK. And I'm going to reprocess the data. But before I do that, let's just draw a quick profile from shallow to deep between the two casts. And you can see it's about 20 meters in the shallows and 70 meters in the deeps. So we'll launch that, do the reprocessing. And while that's running, let's just look at the two sound speed casts that we left in there. There's the shallow one that goes to about 20 meters, and then the deep one that goes to about 70 meters. And if you think back to that depth profile on the bottom of the screen, that shallow cast is going to get used for about half the survey when it really shouldn't be. So once this is done, I've made this data a little bit worse, and you can see there's a big red scar. So this is colored by uncertainty. So this is saying the refraction solution from one line to the next is not good. I've got high uncertainty. And then when I switch to the deep cast halfway through, it's fine, or it's better anyway. And if you draw a profile, you can see that there's a jump of about 1 meter between the area where we're using the shallow cast and the deep cast. So this is the problem that we're trying to solve with the crossfade, is how do I might not be able to recover from that bad sound speed cast, but how do I at least smooth the transition so that it's a little more palatable to the eye? So in this case, you select the files and you run the processing settings, and this is under the sound velocity tab. There's a new area called SVP Crossfade, and you just tick the box and you click OK. And then we reprocess the data when we're prompted, and we should see that that scar, that sudden jump is smoothed out. We can't fix the fact that we used a silly, very shallow cast. This is a contrived example, but it makes the point. And that it'll smooth out that blend. So I go from a not very good refraction solution to a better one, and I do that in a smoother way that's less jarring to the eye. And then if I profile over that, I can see that that jump is no longer there. It's been blended over. All right, so let's jump to the next section, which is talking about a new filter we have in the toolbar called the Isolated Cluster Removal Filter. And what this does is takes the majority of the points in a seabed survey. If you clump them into natural groupings, the biggest cluster would be the seabed itself, hopefully if you're doing things right. And then the smaller clusters are the noise, and they're typically somewhat separated from the surface. So if you see in the upper left, there are a lot of spikes there. What we have is this new filter that lets you identify that those spikes are quite distant from the main clumping of soundings, that's the seabed. It marks them as a specific class, and it does a second pass, and then it marks them to be invalidated. They're still in there, just like a manual edit. You can come and reclaim them if it was too aggressive, but it lets you quickly go from that top left image to the bottom right image with just the running of a simple filter. So let's walk through a little video demo of that. So I've got the same data set that I've been using so far, and let's zoom in on some of the spikes here. And you can see in 3D that the spikes are quite pronounced. I'm also looking at the shallow surface here, not the average. So the spikes are more pronounced than they would normally be. You're seeing the spikes at the true depth of the shoal bias due to the mist tracking. And there's quite a few over in this area here. So just pan around and have a look and see how the shadows really accentuate the spikes. You can't miss the spikes. Even if you zoom out, you're still going to see them. Even if the spike is one cell wide, you'll still see the shadows. So in the filter toolbar, we've got the ability to create a new filter. So I'll create one called the cluster filter. Hit OK, and I'll add one of our custom filters to it. And so let's look at all the filters we have available. If I scroll to the very bottom, you'll see one there, accept only largest clusters. That's the name of this filter. And like with all the other filters, it's quite well documented in plain English as possible how the filter works and what it does. This filter comes from the PCL library, the point cloud library. It's open source, so it's quite easy to get more information about it. There's only a few parameters you have to specify. We've tuned it to have reasonable defaults to work for most people in typical shallow water situations. So I'll leave the defaults, and you'll see that I've created a filter. It's now loaded in my filter toolbar, and I can run over and then apply it to all of my soundings. I'll do that now, and you'll notice that it's running as a background job. And then we'll see the surface clean up significantly after that's run. So all those spikes are gone, just with the simple application of a filter. This is a tool in the tool belt. There will be people who have use cases that will be very, very allergic to using a tool like this. For example, if you're doing nautical charting, you may not want to just use something to get rid of all the shoal soundings. You need to verify that they're actually mist tracking artifacts and not actual shoals. If you're doing other types of work, there's a lot of use case applications where that's not the primary concern, and you're quite comfortable with using aggressive filters. So it's just one of many filters we have there. It's there for people to use if they feel that it's appropriate for their application. Okay, so let's jump to the next section, which is covering R2Sonic TruePix as water column imagery. What this is TruePix is a data modality available from R2Sonic's multi-beams. It's similar to a side scan output, but it also gives the angle information instead of just the intensity like a side scan would. And what we've done is we've taken a round peg and put it in a square hole, in a sense, that we figured out a way to take TruePix and convert it into water column data. And that's what you're seeing on this screen here. And TruePix acts like side scan, that for any given range interval, there's only one return that's available. So in effect, it compresses the water column for you by picking the brightest returns ahead of time. And what that means for the user is that you can run around and collect TruePix all day long, and you're not going to fill up your hard drives the way you would with water column. And what we're feeling, of course, R2Sonic needs to work this out with its client base, is that this might likely be a an alternative to water column where it's good enough and fit for purpose for the vast majority of water column applications, without the penalty of spending all the disk space of water column. So I've got a little demo on that. Let's just jump into that. I'll grab, make a new data set. So this one is just called TruePix as water column. And the data for this was provided on that last screen from R2Sonic and on this new screen as well. So here, one of the R2Sonic technicians was out in the field and purposely collected some data over a rec. So I'll import that and make a dynamic surface real quick, just to see what we're dealing with. We'll leave it at the defaults, 50 centimeters. And here's, I'll just take a side tangent here. You can look at that dynamic surface and it's a little coarse. There's a new feature that you can right click on a surface and change the resolution quite quickly. So if I see that it's a little too coarse, I can choose to change the resolution. Let's go to 1/4 of a meter and then click OK, and that regrids up and I got better resolution there. Okay, so the water column data is accessed as usual through the swath editor. And so anywhere that you've typically worked with water column data in Qimera, TruePix will now work in there as well. And if you have Qinsy DB files with just TruePix, you're going to get water column imagery, except it's from TruePix. If you have Qinsy data that has both water column and TruePix, it will preferentially use the water column. The logic is, if the user spent the disk space on the water column, they probably want to see that first. But we've built in a way that you can toggle between the two. So here we'll just zoom in on this area of the rec, and we'll jump back and forth a few pings. So this is what regular water column data looks like over this rec. And you can see that the vast majority of that imagery is all blue noise from the water column. There's no real signal of interest. Below the bottom, there's a lot of reverberation. That's not really of interest either. So the water column, what you've always been able to do in Qimera is make a stacked buffer. So all of those pings get stacked together and shows you a more coherent image of that rec laying on its side. And what we'll do here, just to show off some functionalities, you can save that picture that you see in front of you as a PNG file to include in a report, for example. So if you wanted to compare, how does water column data compare to TruePix when it's masquerading as water column, you could have this picture here. And then what you can do is, there's a new option in the filter settings for water column to override the water column use with TruePix. So this is for the users that have TruePix and water column. If you want to use TruePix instead, you do this. You have to click OK. And then for now, we just have to restart the swath editor to load TruePix instead of water column. And when this loads up, we'll see what that same data set looks like with TruePix data. So you hear just a single, that's a stacked buffer of a few hundred pings. We'll save that fan image too, so we can include that in report, or after the fact, we can compare these two. If anybody's interested, just say so in the chat log, and I can send you those two images so you can compare for yourself. So we can zoom in and we can see that the rec is quite well defined. And we'll switch to a single fan view, and that's what it looks like. That's the center ping in the ping buffer, and we'll advance a few pings at a time until we're over the rec. And you'll see the TruePix data picking up the rec right about now or so. And you'll see that most of the screen is black. That's because TruePix didn't bother saving data for areas that weren't of any interest. And that's determined by the brightness of the returns in a single range ring. So the rec's quite well defined here. And you can do all the normal things in the water column tool. You can digitize points. You can geopick one to get an instant georeferenced, vertically referenced points. For example, shoaless depth over a rec if you need to know that for your next pass in the multibeam, or if you want to report a danger to navigation. You can also do the side stack buffer. So this is showing what the TruePix data looks like when you do a side stack of all those pings. And you can click in here and isolate. For example, in this case, I'm jumping to the shoaless point on that rec to get me to that ping. So that is the TruePix's water column demo, and we'll take another break for questions here. So Evan, Matt, is there anything that's come in about these last three topics?
One question, JB, about the isolated cluster filter. How is this an improvement over the existing spline filter?
The clusters try to respect the fact that things that are distant from the main surface are probably different things. So a clump of fish or bubbles or just a mist track or sonar interference up in the water column, it is going in like a laser and saying these points are distant from the main clumps. So it's smarter. The spline filter takes all the points and treats them all the same. It isn't really morphologically aware or aware of the fact that some points are disconnected from a main clump of points, and it doesn't take advantage of that. So the cluster filters is much smarter in that regard, and it will handle outliers. The spline filter, if you don't quite get the right spline filter running, it can be a little sensitive to outliers, and it'll preserve some and then end up blowing away part of the seafloor. So I think historically users have had to tweak which spline filter they want to use, or they custom create their own with custom parameters.
Okay, thanks, JB.
Yep. Anything else?
That's it for the moment.
Got a quiet crowd today. Okay, let's jump to the next section. So we're going to switch gears a little bit, and part of Qimera's job has been to replace some of the workflows for Fledermaus users. Fledermaus users over the years have seen functionality in for LiDAR data. So that's typically been airborne LiDAR and more typically focused on airborne bathymetric LiDAR. So we've had a user base that's been in Fledermaus. We've told them that Qimera is the next generation workflow. So we need to preserve some of those workflows and then potentially augment on them. So here, the next little section is about things that are in place for bathymetric LiDAR data processors. And these types of people typically have point clouds that come from airborne LiDAR. They're not here to do application of patch test offsets or calibrations. They're typically here to review the point clouds and then remove the bad points, potentially do some other kind of classification work. So what we have in this release is the ability to have classification brought along. So if a LAS file, that's a typical file format for LiDAR, can have a field for each point that has a classification. In terrestrial LiDAR, there's quite well-established classification schemes. In bathymetric LiDAR, less so. They tend to borrow on the terrestrial ones, but the feature types in the terrestrial classifications are very focused on terrestrial applications. And I think things in the water are all lumped into one category. So there is some movement in that community to have the classification schemes expanded. For now, we've provided the instrumentation that if there is a classification, you can see it in Qimera and you can work with it. The other thing that's new in Qimera 2.0 is the support for RGB. A lot of the times the airborne LiDAR is collected with photography from a downlook camera. And there are applications that can have the point cloud colorized based on those downlook photographs. So each point in the LAS file can show up at the front door of Qimera with a classification and or an RGB coloring. So both of those are supported now. What I'll do is just start a little demo video showing off that capability. So here we'll just create a new project, RGB and classification demo, and I'll add some data to the project. And here they come as processed point files. LAS files are binary collections of X, Y, Z data points. They have a different import pathway from raw sonar files. And I have a file, this is an open source data set, I think from somewhere in the middle of the US. It's a terrestrial data set. So you'll see there's a river in there, a lot of buildings. So we'll bring that in there. And once that's cooked up, we'll create a dynamic surface. And we'll make it a 5-meter grid. So let's see what that grid looks like. And you'll see there's buildings, what looks like a river, little community. If you click on the dynamic surface itself, what I typically do with airborne LiDAR is I change the depth layer to shallow. When I'm looking above, I want to see the tops of the trees, not the average of the top of the tree and the ground underneath. And so that helps the picture just look a little bit more reasonable, that you can see and assess with your eyeballs what's going on there. So that's the typical workflow I do. And let's just draw a rectangular box selection in the middle. And we'll jump into some of the editors and have a look at what the point clouds look like. So I've got a box drawn here, and I'll run the slice editor, and it'll load those points up. And now these are colorized by the Z value. And we'll launch the 3D editor as well, the 3D slice. So that's the one that we looked at earlier in the webinar. And you can see those are also colorized by the Z value. So let's have a look at some of the new coloring options. You can color by classification here. So that's the last one at the bottom of the list. And you can see these use the same file colorings as we do when coloring by file. And if you look at the very bottom below the slice editor, there's a text readout as you move your cursor over. That will tell you the class. So as I move over, the trees, for example, are class 1. And then the ground underneath is a different class. And you can have that from the 3D editor as well. So if we jump up into the 4D scene, you can colorize differently there, and this one will show off the RGB coloring. So it gives you a sense topographically what you're dealing with. The point sizes are drawn, and those are scalable as well. If you zoom in, you'll see gaps in between. You can also color by RGB in the slice editor and the 3D editor. So we'll bring it back to classification. There's a few new filters, and those will just pop up in the video in a second here. But before we do that, we'll just leave the slice editor. And we'll create a new custom filter, the same way we created the cluster filter. We'll pick one that rejects, we'll call the name of this filter, reject class number 1. Click OK. And now I add a filter profile to it. Filter to the profile, the plus sign. And at the bottom of the list, you'll find the new profiles. So the second one from the bottom is reject or accept specific classifications. There's a small explanation of what you can do. You can do comma-separated lists or individual values. You can choose to reject or accept. And recall that you can compound these. You could reject class 5, you can accept class 4, and stack these in the same filter. So once I click OK, let's have a little look at this area down here. And we'll run the slice editor. And you can run any filter that's loaded in the filter profile window with the filter button in the slice editor. That gives you a preview, and you can see those are all colored gray now once I hit it. Those are the things that will be rejected. If I hit save, that'll get propagated to the scene. The QPDs get updated and the grid gets updated. And you can see if we leave the slice editor now that we've rejected all of those buildings and trees that are in that area. You can also use this filter on the filter toolbar. There's an instant surface filter. And what that does is lets you draw polygons on the grid. And you're not looking at point clouds at all. You're just working on the grid. And you can kind of go into Godzilla mode where you're just going to go destroy these neighborhoods and knock out these buildings. Here's a little bit of a RV camp, I think. You can lasso around that. So it's just showing that some of the different ways you can use these filters. You can use it in the slice editor to preview. You can apply it to the whole grid, or you can spatially select the area you want to apply it to. And of course, we keep track of which ones are rejected by a filter like this so that you can go and recover from that if you made a mistake. So let's look at another tool that we built in, is the ability to set a class. If you load up last data and there are no classes at all, the class will be by default in Qimera 0. And let's say you wanted to go around and use your own classification scheme. Let's say you're trying to isolate anthropogenic structures on the seabed. If you have nearshore bathymetric LiDAR, here we'll set the classification scheme, set it to 5, for example. And now I can use that same tool in the toolbar, Instant Surface Filter. So you see that set class 5 is chosen. And now I can draw in the scene. And what I'll do is, for the sake of being quick, I'll just lazily draw the outline of the river and capture this as a polygon, just to show how this type of tool might be used if you wanted to do some basic classification of data. And then that filter is applied. there's no actual effect on the grid because the Z values don't change at all. So if we come back to the slice editor, we can colorize by the class and see what that looks like in the editors now. So draw a rectangle selection, run the slice editor, and you really can't see it in the 2D slice view, but if you run the 3D editor, the 3D slice, you can. You see there's a new color on the river there. And if you look down at the bottom, you see that's reported as class 5. And you say the same thing can be done in the scene. The river points are now classified as class 5, whereas the trees and other things have different classes. And then the interesting thing about this is if I have those last files, I can unload my edits and also reclassifications back to the last file so that I walk away with the same file. It's just a little bit better than it was when it first showed up to Qimera. You can also re-export them as a brand new last file. That'll have your cleaning edits and the classification changes done as well. So you could use this to start doing classification work of your bathymetric LiDAR data and even terrestrial LiDAR data. There's quite a rich tool set in the community for terrestrial work. We tend to play the sweet spot and be in the water and on land a little bit, and that's where we tend to focus our work with LiDAR work. Okay, so that's the end of that demo. I'll switch to the next one, and this is the last one. We're going to talk about a new add-on that we have. SFM is Structure from Motion. That's a bathymetric refraction corrector. That's the name of the add-on. Here's a pretty picture. What I'll do is I'll just jump into a slide to quickly explain what that is before we do a demo of that. So Structure from Motion is, in a nutshell, automated photogrammetry. For those that don't know what photogrammetry is, it's a technique that came after World War II, where you're flying around with a camera looking down and you take pictures. And if there's enough overlap between the pictures, you can pick points that are in common and you use the parallax between them. So the difference in the along track position, depending on viewpoint, to compute the XYZ coordinate of it. So it was a way to do rapid aerial surveys after Second World War. What Structure from Motion is take that same idea, and then a couple of things will happen. A, we have small UAVs and aerial drones now, so you don't need an aircraft. And then B, we have the computing power and algorithms that you can just dump these images into a cloud-based processing service, for example, and out comes a full, rich 3D point cloud. So this is happening, and it's exploding all over the terrestrial mapping world. Where it's interesting for us, because we live in the water and on the land a little bit, is the folks that do coastal zone mapping work at the land-sea interface. So they might be doing a bit of acoustic mapping in the water, and they need to get at some of that water, the water depths that are just typically out of reach for a platform on the water, just because of safety of navigation. What kinds of mapping techniques can you use there? So this is interesting in that when you take aerial photographs, if you look at remember the last picture, actually I'll just jump back a slide. That's a photo mosaic of a UAV flight mission. You can see underwater, you can see points underwater. And if the points can be seen, then the algorithms can turn that into an XYZ position. And so is that data correct? And that's what this refraction correction is attempting to do. So there's points underwater in the photographs, and then they spit out an XYZ solution for that. So what we're attempting to do is just a real quick and dirty optical refraction correction. And the analogy is that picture in the lower right of a pen sitting in a bowl of water, and there's a bend in that. And that's very well described in physics. We understand this quite well. If you know the entry angle of the pen and you know the refraction index of water, you can predict the bend, the appearance of the bend in the pen. And then you could then back calculate, well, where must it truly be? I can look at that picture and measure an XY coordinate in that picture frame. It's not the true position of the tip of the pen in the water. So what we're trying to do is provide that same simple mathematic capability for these underwater points. So I'll go into a short demo about this now. We'll make a new project. So SFM demonstration, Structure from Motion. If you Google Structure from Motion, you'll find that there's quite a bit of information out there about this. The typical output we see for this is also LAS files, so typical point file exchange format for the bathymetric LiDAR, topographic LiDAR. This is data from 4D Ocean, Duncan Malice collected with his drone. So we'll bring that in. We'll let that convert to QPD. And what we'll do in the meantime is we'll import the image. The software that Duncan uses also creates an ortho photo mosaic of the entire mission area. And you'll see now that this is an improvement in Qimera 2.0, that when you import an image, it's a background task so that you can carry on doing other work. So the image appears, we'll select the files. Now we'll make a static surface of this. What I want to do is make a before and after. So I'm going to choose a static surface instead of a dynamic. So we'll look at the point clouds, the terrestrial ones, and also the underwater ones that come directly from the SFM processing algorithms. We'll look at how these look coming out of the box. We'll create a grid of that. And what's interesting is the power of the Flight of Mouse visualization engine. We've got this grid, the terrain model from the SFM mission. What we can do is select the photograph and then drape that on top. So you choose the static surface and you go to the mini attribute panel below. You click Drake image and just expand that dialog a touch. There's the image that I just loaded. I click on that and that chews away for a few seconds on that. And then the image is draped on top of that terrain model. So it's a 3D terrain model that comes from the SFM mission, and it's been colorized by the photograph. So I'll just zoom in 3D on that, and you'll see that the image itself is still in the scene. We'll just turn that off for visibility. It's shown below at a different Z value. And now I've got a 3D terrain model. This is what comes out of the online processing software that Duncan uses. So this is typical deliverables from that. So we'll zoom into a little area that's where the water's breaking on the rocks, the reefs, and then we'll draw a little profile along there. And we'll see if we can identify the land-sea interface. And this is where the draping of the image is quite important. You can see that with your eyeball. Those rocks look dry on the left, and then it looks like water after that. And if you draw a profile, you can then put your mouse down in the profile window, and there's a little red ball in the scene that lets you isolate the depth at which that happens. And what we're looking for, all of this data is ellipsoidally referenced. We're looking at what's the instantaneous water height referenced to the ellipsoid for this point cloud, so that we can do the refraction correction of the points that are below that and only below that. So right now it's about 54 meters according to that. So there's an SFM correction tool in the utilities menu under the tools menu. And the only inputs are the water height that we just measured, so 54 meters. We'll leave the refraction index as it is there. And then we'll click OK. And that's going to run on the process point files that you have currently selected. So if you look in the tree view, I still have all 4 of those files selected. So it's running there. And what we'll do when that's done is we'll create a second static surface. We'll call that after. And then we'll look at a profile between the two. We can compare what the correction did and see the magnitude of it, etc. So we'll create the after surface, and we'll do the same trick. You can see that the surface is just drawn at the same Z level. We need to drape the image on it again. So we choose the after surface, go to the same drape tool, choose the orthophoto, and then click OK. And that drapes on. So now I'm looking at surfaces that are the same. And I can profile across them. And if I have both surfaces drawn for visibility, then the profile tool will draw on both of those surfaces. So I'm drawing from the beach down to the edge of the orthophoto. And you can see that the profiles are labeled. What we'll do is we'll colorize the before as red. And then we'll leave the after as green. And as you click on them on the left, you'll see that it lights up in the profile view. And if you mouse over them, you can see that the depths are reported. And you can see where they start to diverge, and that's about the depth of 54 meters. So anything below an ellipsoidal height of 54 meters is considered an underwater point for which that correction is applied. So this is an add-on. If you're interested in this at all, this won't work for you out of the box in Qimera. It's quite simple at the moment. So we're interested to hear from users that are willing to try this out. There's still some more math that needs to get explored to do more refined corrections. Duncan works with this in a way where he collects bathymetric data in the deeper water with his ASV, and then he uses that to match what he's getting from the drone data. And so he's forcing the drone data points to match the multibeam data points. So he's got a bit more confidence in what he's doing. So we're interested in hearing from users that want to try this application. We've shown this at a few conferences to date, and we have a small list already. So we'll be getting in touch with those users. But if anyone else is interested, please contact us at sales@qps.nl, and we can arrange for a demo of that add-on to be enabled for you. All right, we'll take a pause for questions now. So Evan, Matt, anything from the crowd?
Yeah, JB, a question about the LiDAR functionality. Does Qimera 2 export LiDAR data with RGB values back to LAS files?
I think if it showed up with RGB, it will go away. I have to confirm that. I'm not going to assume the answers yet. I'd like to think so. So I'll get back. If you can just jot down the person who asked that, I'll follow up with a good answer. Okay, sure thing.
And that's it for, well, there was good interest earlier in the TruePix. If a question, if we had any technical documentation or white paper available on hand for that.
Nothing really. We've updated the reference manual to indicate that if you have TruePix, it'll just work if you're coming from Qinsy. We've updated the reference manual to show you how to switch between water column and TruePix if you have both of them. It's something that I'd be interested in maybe preparing with R2Sonic. At the end of the day, TruePix is their technology, and I think it'd be better described by them. I don't mind giving them a hand with it, but that's something that I'd be interested in participating in, but we don't have anything prepared.
Okay, thanks. That's it for now.
Okay, so that's the end of the demos. What we'll do is we'll switch to looking towards the future. What's next? These are our plans. So for Qimera 2.1, what we're going to plan is a quick fire release with some small feature improvements slated for Q4 this year. And what we're going to focus on is we had some leftover items, but first I'll touch on this. What we want to really do is get to a world where you can get as close to an instant open experience as possible coming from Qinsy. Qinsy has the power to compute a lot of the metadata files online, and Qimera has knowledge of all the Qinsy file formats. What we want to get towards, one release after another, is to a spot where you can go offline with Qinsy and then literally open the project in Qimera, and it appears instantly if we can pull that off. So that's a high-level goal of ours, and we're going to be making steps and strides towards that with each release. So we've made a number of improvements in this release with the QPD scanning operations. If you read the release notes in the performance section, there's some impressive improvements there. So we want to keep on that path. So you'll see some more of that. What we also need to do is start looking to building an alternate patch test tool for Qinsy users. We have the patch test tool for Qimera users. The Qinsy users can come to it and use it. What Qinsy users have, though, is the validator patch test tools, which ship with Qinsy. And if you're in Qinsy online, you can just use them. But those tools are quite old and they need to be updated. What we'll be exploring is a way to bring Qimera to a Qinsy user so that if you have a Qinsy license, you can just run Qimera in basically a patch test mode, where you can start doing patch tests, but you don't need to have a full Qimera license. So we'll be looking at a way to box in just the patch test capability. That'll largely benefit Qinsy users. What about people that aren't using Qinsy? Well, we're going to have patch tests for laser scanners as well. That's something that we specifically disabled with earlier releases. So we'll be looking to remove those roadblocks and then figure out how to get that done well. We'll be starting out by allowing the tools that ship right now as a patch test to be used with laser scanners. This is primarily aimed at Qinsy users as well. Qinsy can let you shoot multi-beam and laser scanners at the same time. So you want to be able to calibrate all of those. For people that don't come from Qinsy, this is the big improvement we're going to have. There's quite a number of requested improvements to the patch test tool. In fact, that's one of the top voted items in our feedback project. So that's coming for sure. We have made a commitment to laser scan patch test and general improvements with 2.0, but we weren't able to deliver on that. So what we're doing is just sliding this into the next feature release. So here I'm committing to that at a high level. And we'll be looking at the feedback top voted items. So let's just switch gears for a second and look at what's left in the feedback project now that we've satisfied quite a number of votes and items in Qimera 2.0. So on the left, I've got the top 10 is on the left, and you can look at the very first one. FQM44 has 43 votes. That's patch test tool, general improvements. So if you can log into Jira, you can go have a look at that, and there's maybe a dozen or 15 bullet items about general improvements that people have asked for with the patch test tool. So that's something we're committing to. The second most voted item is being able to do laser calibration with the patch test tool. So there's quite a host of other items in there, you know, creating spot soundings with 23 votes. If I look over on the right-hand side, that's the second set of top 10 items. For the offshore wind farm industry, for example, with 16 votes, is adding the ability to have THU and TVU layers. So there's a real mixed bag of feedback items with a lot of high votes. So we'll be plucking about 15 of those at least, including the patch test ones, and delivering those in the release in 2.1. And then looking back at our feedback track record, here's on the right-hand side showing the feedback items that were resolved with 2.0. So we've got 37 that we've resolved. We had aimed to have 15 or 20, so we've overshot the target. You can see them listed there in the votes. So you see a lot of top voted items. The number one voted item at the time when we started 2.0 was being able to have control over the color map in the slice editor and also in the 3D editor. So that's in Qimera 2.0. So this is allowing us to for honesty and transparency. What are we solving and why are we solving it? What are our criteria? So we've did 37 items in Qimera 2.0, like I said, and since we released Qimera 1.6 a little over a year ago, we've resolved 58 items to date. And that's, so let's round that up to 60. Currently in the feedback project, there's about 300 items, not including those. So we've bitten off about 1/5 of those, and the votes are doing the talking. We occasionally have to drill down to some low voted items. For example, we have some clients that have one point of contact that goes into Jira and they place one vote, but they might have 20 licenses. So effectively their vote is like 20 licenses. So sometimes you'll see that there's lower voted items in there, but that's typically the reason why. And then speaking of votes, to date, since we've started using the feedback project, we've satisfied 262 votes overall. So why are we doing this? The feedback project, we want to build what you want. You tell us what you want. People are very good at telling us that. We take great notes during our training sessions and client visits and workshops. That gets put in our Jira system, and then people can go in and we convert them into anonymized general feedback items that people can vote on. This lets everybody see what the whole user base is asking for, and then we can see where the voting trends go. And we like this because it's open and transparent, and everyone can see what we're up to. We can make commitments. We say we're going to deal with the high voted items, and people can see that, and then when we deliver on that, that hopefully makes it a bit more predictable for you to use our tools. So that brings me to the end. So I've got a final wrap-up slide here, and I guess we can just take general questions.
No more questions, JB. There's a couple of people I'll follow up with offline, but just want to thank everyone for the questions and for attending.
All right. Well, there's, I think, 2 minutes left. So if anybody wants to stick around and if they have a last-minute question, Matt and Evan and I are here till the top of the hour. Otherwise, we'll wind down then. All right, I think that brings us to the top of the hour. So thanks anybody who's hanging on. We'll see you at the next webinar. Thanks, Matt and Evan. Matt, you can go ahead and tear everything down.
Roger, thanks, JB. Bye, everybody.